Okay, so it's just gone past 4:01. We might just kick off for this webinar today. Again, my name is Samir Jacob. I look after the marketing communications for Clenergy globally. Today we have today with us all the GreenTech customers. Welcome to Tech Talks from Clenergy College. I'd like to introduce your speaker for today, who is Andreas Rastelli. He has a background in engineering and project management and a degree in civil engineering, and a lot of experience within site and structural assessments, and especially on construction sites. He is one of our sales engineers, and so without further ado, I'll hand you over to Andreas.
Thank you so much for the introduction, and thank you everyone who is joining on for our Tech Talks. I want to first give you a little bit of introduction of what are we going to cover today on the Tech Talks. And so this session is called PV Mounting Systems, The More You Know by Clenergy Australia. We'll be awarding 35 CPD points at the end of this training. It's just 8 questions for you guys to answer. So welcome to today's training. What are we going to cover? So just browse up a little bit of the topics that we're going to be commenting a little bit today. So we're going to start off with roof zone definitions, what they are, how to calculate them, and what to take into account when doing this. Then all you need to know about our screws, different types of screws that we've got for penetrative interfaces. Then we're going to cover dissimilar metals and corrosions, concealed roofs and their weakest points, also how we test them and how the interface connects and interacts with the whole system. We're going to also cover a little bit more about the 2 types of generic, the engineering certificates, which are generics and project specific, then how to earth bond your system correctly, and what does the standards recommend us to do when installing. And then we're going to move through thermal expansion and maximum rail lengths, and finishing with different roof types and mounting methods, including concrete roofs and what to do with them. So let's have a start. So, all right, I'm going to start covering roof zones for flush mounts. What are roof zones? Basically, roof zones are sections of the roof where the wind pressure is higher or lower compared to other areas. This is because the wind doesn't interact and it's not the same pressure all over the roof on the systems when we install them flush. So what are exclusion zones? Exclusion zones are areas that we're not allowed to install. Either they are exposed to highest wind pressures or they're simply not permitted to install. And this is generally along the edges of the roof plane. So how do we determine this? So basically, at Clenergy, we consider the Australian standards 1170.2, which is the wind load and wind assessment for structures for solar. So the first thing to assess would be the dimensions. So the height, the width, and the length of a building. Those 3 values are very important in this assessment, as this will determine how to divide the roof and how to proceed. So basically, we have 2 conditions when we evaluate roof zone definition for flush mounts. The first is when the height divided by the length is equal or less than 0.5, and the height divided by the width is less than 0.5, or when the roof pitch is between 1 and 30 degrees. So what do we do here? When these conditions are present, as we can see in that image right there, we have the length of the roof, which would be B. And if we separate B into 3 same equidistant lengths, we'll be able to see where the end zone and the central zones are. So the end zones would correspond to the upwind and the downwind sections of the roof. Also, these standards recommend to have a minimum exclusion zone of 2S. S being the distance from the underlying of the panel to the surface of the roof. All right, moving on. What about tilt systems? How do we proceed with tilt systems? So basically, with tilt systems, we have 4 different types of roof areas, which are internal zone, intermediate zones, edge zones, and corner zones. Now, how do we determine this? So it basically applies the same condition with the height and the length and the height and the width. The first thing we have to determine is the building height, and then choose the lowest value between the height or the width times 0.2 or the length times 0.2. The height is not to be multiplied, but considered in its entirety. So the lowest value from the step 2 would be equal to A. Now, as you can see on the diagram here, the A would correspond to the corner zone area. And being A divided by 2 would be the difference between intermediate zones and edge zones. Moving on, this is just an example that we could use to determine. So basically, this is for a flush system. The pitch is 5-degree pitch, the height is 10 meters, length is 50 meters, and width is 15 meters. So what happens? H divided by width is not equal or less than 0.5. Then we have to divide this as it would be a tilt system. And therefore we can install like this. This is just when the condition number 1 is not met, then we have to subdivide the roof as it would be a tilt system. And here we have the height 10 and B and D times 0.2. As you can see, the lowest value would be 3 meters. So in this case, the A would be 3 and A divided by 2 would be 1.5 meters. So that's how we can divide in this condition. As you can see here on the different zones, then we would have from the edge of the roof inwards, then that's how to divide the roof and how to install it aligned with all the standards. All right, now we covered this. Let's move on to the different type of screws that we have in Clenergy. So basically, as you can see, there are 2 types of screws, the universal screws. One is, on the left one would be the wood screw, and on the right side of the screen will be the universal screw for metal. So what are the difference? Basically, the difference, as you can see, one is a fully threaded rod, and the wood screw, the tip is slightly different than the tip on the metal screw. This is to allow to install the purlins and different metal members. Whereas with the wood screws, you can install on timber and battens, and that doesn't matter. So general notes here, do not reuse the existing screw on the penetration. Always you would have to go up one size up from the screw that pulled out. And obviously we would have to be very precise to match the corrosivity environment, as this can be used on C1, C2, and C3 corrosion categories. All right, covering a little bit more, here we have a standard warranty for these installations, whereas it's for tin or for tile, and a little bit more of the material. So we got carbon steel SAE 1022 with a climate sealed 3 finish. This is the AVW washer. And so as you can see, it is it covers 10 years for C1, C2, and C3. And we have different type of warranty for these screws in Australia. So how can I determine the corrosion category for my project? All right, easy. We have 2 options. The first option would be to contact us. We got a technical engineering support team that can provide you a recommended reading of your installation corrosion category. Now, all of our technical engineers would follow the AS4312 standard for the atmospheric corrosivity zones in Australia. This is just an example of how to read and interpret the corrosion standards. As you can see, with concealed base, there is a little bit of a difference, whereas to fully exposed shores to the ocean, it changes a little bit. So this is just an example of what happens in Melbourne, as it is a bay which is concealed. So as we can see here, the majority would be C2 and the coast would be C3 without any C4 or C5. This is because the shape of the bay, Port Phillip Bay, would cover a little bit the full exposure of the saline sea. Another example would be what happens in Sydney, which is a different scenario here that we have exposed completely shore to the ocean. So basically rough seas, ocean fronts, and anything between 200 meters and 1 kilometer would be considered high corrosive. And here we do have C4 and C5, which is basically in the coast and around the bay in Sydney. So that's the highest corrosion category in Australia. And this would impact and would have a clear direct on the metals. So we're going to move and talk a little bit more about dissimilar metals. What are dissimilar metals? Metals with different core properties, which have an increased risk of galvanic corrosion. What is normally known as white rust, when two types of metal are in direct contact and are not compatible to be installed without any rubber or any material in between. How do we identify this? Well, we refer to the series of metals on the table, which shows the highest noble metal along with the active metals. So on one end, we have the noble, and on the other end, we have the active metals. Metals close to each other will not be recommended, as would be a very high risk of causing galvanic corrosion. It would mean that they are similar. So metals that are far apart are considered dissimilar, and we have no problems with installing. So let's check what happens with gold. Gold and stainless steel SUS 304. So there is no problem with this compatibility, as they're not in the same class. A common material for the color bond and many roof sheets is an aluminum or magnesium alloy. So what happens is the majority of our interfaces are stainless steel, and we can see the difference in how far apart they are on the table. So it is not a problem. All right, covering more a little bit and talking about the clip lock roofs. So what about the components I use or when I clamp to a clip lock roof? Now, this is what we were covering on the previous sheet. The two types of metal present when we use a clip lock roof interface directly with with one of our interfaces. So our interfaces are aluminum AL 6005, and the direct contact is considered to be compatible with low risk of galvanic corrosion, as other types, clip locks and other type of roofs are almost all made of steel. However, they do have coatings, which can be the ones that we have stated here, aluminum zinc or aluminum zinc and magnesium alloy. So it's not a problem, and these metals are considered to be compatible. In summary, so galvanic corrosion is accelerated when you have two distinctive dissimilar metals on opposite sides of the spectrum, noble and active metal. Aluminum clamps and fasteners are considered compatible to be in direct contact with concealed roofs such as clip lock 406 because of its similar aluminum zinc magnesium alloy coating. Now, also the majority of these brands are covered here: BlueScope, Lysad, Fielders, and Stramit. So we can also find more information about the material compatibility, or contact us at tech@clenergy.com.au if you are unsure. We can check this for you and also provide a technical feasibility of your materials. So let's move a little bit more and let's talk about concealed roofs. So what are concealed roofs? Basically, concealed roofs are exterior roofing sheets that are not visible, are not screwed directly into the purlins or battens, and they lock into each other without the need of any visible screws. They're really easy to install. They eliminate the rust or leaks due to exposed screws, and they're very common with commercial building installs, new housing developments. All right, so what common types we see out there? Well, I mean, working in Clenergy, we already see majority and the standard roofing sheets, which could be Clip Lock 700, either classic or high strength, Stramit Speed Deck, King Clip 700, 406, strut coat top deck, and the list goes on. So how do we identify a roof type? The common practice is to see the length, the rib height, and the profile type, but also as we are not available to identify the correct roof sheet, this can be identified on the bottom on the underlying on the sheet. So on the back side of the panel, you would have a label or tag identifying the roof sheet type. And this is how we can proceed. So we can locate the label, or if you've got any architectural drawings or any information at all about the aesthetics or what type of roof sheet is installed, they normally be in the architectural drawings. Why is this important to identify correctly? So this is crucial to have in mind, as we can see that every roof sheet has its own capacity and different capacity to hold onto these clips. So as we can see, a lateral view here, the roof sheet actually clamps to these clips, which is called the fixing clips. Now, this is basically what supports your roofing sheet and what anchors the roofing sheet to the structure. So basically, this is the first point of failure when we test all of our systems. The deforming would be the deforming clip. The fixing clip would ease and give way. So it is really important that we identify the correct roofing sheet, because all of them, they have different capacities. And we have tested them with our laboratories that are NATA certified. So it's really important to have a correct roofing sheet and to identify it. So as I said before, the connection point between the roof sheet and the clip is the weakest point on the system. And I will show you guys, moving on, some pictures of how we test them and why it's important to identify it correctly. So as we was talking about, our testing partners are NATA testing labs. And this is just an image of how we test an ERI 09. So this is the failing point when the clips are completely detached of the structure. It would look at this like this. So this other views and how we configure the testing procedures at our MTS and ATA laboratories. So MTS is Melbourne Testing Services, and they're located close to us in Clayton. So just to share with you guys, the couple pictures of when we achieve the purlin and the rib failure. How does it look? So it completely detaches from the concealed roof sheet, and it is no longer then attached to our structural roof. This is why it's really important to know the roof sheet and for us to calculate the exact spacings on the roof and the maximum installation spacing. So moving on, we're going to just give you, this is just our range of non-penetrative interfaces, which, and obviously all the roof sheets that they are covered. Now, we're able to certify and cover all these roof sheets because we have done all the testing procedures for each of every one of these. So all these combinations have been prior tested, as we showed on our MTS lab. So in case you have any doubts, or you're wondering, you've got a project, you have identified the correct roof sheet, but you don't know which interface to use, this is when it comes to play. And it's really, it's something that helps us when we are designing a roof system. So the correct interface with the correct roof sheet, and basically this is the compatibility chart. Okay, moving on. What happens when my roof is not listed, or when my installation falls outside in standard certification? We have several options here. The first one would be a penetrative fixing. So discard the non-penetrative interface and then try to locate purlins, battens, or rafters. The second option would be on-site testing. The on-site testing is shown as the picture on this slide, where basically a frame is set up on top of the roof sheet with the interface click on the clip lock roof. And it then applies certain uplift pressure until it detaches. And that's how we calculate the maximum capacity of the roof sheet. That's our second option. But if we on-site testings, sometimes it's not that economical. So if we do not want to incur in this, we can always over-engineer using the worst case scenario. So sometimes we can assess and we can guarantee certain loads that would be at least as a worst case scenario. So covering the two types of engineering that we've got in Clenergy, I'll give you a little bit more information on what are these. So the standard engineering certificates are designed for residential and small scale commercial projects. They are a set of conditions and it is basically to cover a range of wind regions, terrain categories, building heights, also roof pitch and elevation. So we do not include the roof structural check, and the spacings are conservative. As we already said, the safety factors that we recommend to use are basically tied out to the capacity that MTS provide us. So to this capacity, we add some safety factors as well to remain conservative. So the standard engineer certificate would not be recommendable or suitable for high-profile projects or large-scale when we have to optimize the spacing as much as we can. The project-specific engineering, the difference is that it's suited for commercial systems or large-scale systems. It could have any condition or design parameters as we design this condition based on the project requirements. It includes a roof assessment, and we optimize the fixing spacing for roof zones. So what does that mean? The generic certificate, they have a set of spacings already calculated. With a project specific, it will enhance this spacing and it will completely reach out the system full efficiency. And it often is required for tendering or regulations or high profile projects, or sometimes it is required by some councils. So it's good to have in mind that two different types of engineering certificates. The standard engineer certificate is available on our webpage on clenergy.com.au, and we can check this out at a later stage. The project-specific engineering, they have a fee. They're not free, and we can quote them from an engineering department, and we can provide a preliminary assessment free of charge. So how do we get a project specific? This is what I'm trying to get at. So the first step would be to send an email to engineering@clenergy.com.au, and we can coordinate this for you, where we provide a preliminary analysis free of charge. We can also provide custom solutions, recommendations, or any types of project support that you require. And for instance, some systems, for instance, we do require different forms or different certificates to go with the state regulatory forms. So for instance, on Queensland projects, we require Form 15. And also drawings, designs, any types of project support or drawings specifics that you would require for your projects, and much more. Customized designs and different types of installations as well. So let's move on to the earthing and bonding. So why is it important, and why should we earth and ground our solar array correctly? So according to Australian New Zealand 5033 standard, there are 3 reasons for earthing the exposed conductive parts of a PV array. Number 1 is to protect and provide a path for fault currents to flow. Number 2 would be as a lighting protection. And number 3 is to have an equipotential bonding to avoid uneven potentials in installation. This is also to remain safe and not expose any of our installers to a risk that could be avoided. So how do we do this with the Clenergy components? We have basically the grounding clips, which part number is EZGCST. And we can see the different forms of installation, how it's correctly installed and how not to install it. And we have the grounding lug, which is the EZGLST. And we can see here the correct installation mode and how to pass the copper tube. So to successfully earth and bond arrays, we have three different methods, which the first one would be even and odd. As we can see on the top and the bottom image, it basically has to cover all the panels. So we have to ensure that all the panels are properly earthed and connected to each other. The X locations will mark where to install the grounding clips. So the first method is this one. Then we have the zigzag method, which we can also use. And the third method would be all the interclamps. All right, so to summarize, earthing components are to provide electrical path or continuity to the ground. Earthing clips and lug, when fixed properly, will pierce through the anodization of the rail. So this will give you a direct contact to the metal and not to the coatings. And you do not have to add a clip under every mid clamp. However, when you do remove a panel, an end clamp should be fastened to maintain safe earthing and to secure the panel. So this is very important to remind when we do maintenance and when we have to remove panels for any reason. All right, so moving on, we are going to cover the thermal expansion and rail lengths. So what is thermal expansion? We have to remember that when we have our systems in direct contact on the nature, right? And these are going to be subject to high and low temperatures. So basically, thermal expansion would be when there's a difference in temperatures or change in temperature. As you can see in the image here, all the rails that are exposed directly, they are directly subject to these changes. So what is the maximum length of rails that we recommend to avoid having any issues with the thermal expansion? All right, we recommend maximum 20-30 meters, and then to use a splice, because the splice will assist, and it will also, the splice absorbs part of the thermal expansion, the compression. So this would be the recommended length for eco rails. In some location, there's little impact, as we've explained that the splice absorbs part of this. So we can also go length up to 100 meters lengths, obviously spliced together. Please check with us if you require long spans for your projects, and we can ensure that there wouldn't be any issues with the thermal expansions. All right, so we're going to talk about roof types and mounting methods. All right, so on the first types of roof, we get the ERI05, which is our tin interface. Basically, is for penetrative systems and for trim deck and trapezoidal type of roof. So we have the ERI05 in silver and in black anodized. Then we also have other subcomponents of the same interface, which would be the ERI with easy click, or the ERI25, which basically has the puck on the bottom to match the curvature roof of the corrugated roof sheets. Let's move on to tile roofs, tile interfaces. So we have slate tiles, terracotta tiles, Spanish tiles, and other different types of tiles, but these are the most common ones in the market. So this gives us a little bit of information on the ones that are mostly used. So we have a wide range of tile interfaces, which basically depend on the dimension of the actual tile and the height, which would be from the ERI01, the ERI02, the 51, the 23. And what do I do when the brackets are not aligning well with these tiles, or when I can't reach the rafter? So we can use an option. The first option would be to use packers, but always guaranteeing that we have at least 35 mil embedment or 25 embedment in the rafter. This would just mainly be for a structural purpose. So timber screws at least would require 25 to 35 mil embedment. And when we have a height issue, we can always use the EZRE200, which is the roof extender. All right, so giving a little bit of product sneak peek and new items, we've got the adjustable tile interface. So from the adjustable with the easy click connection, here we have that will give us a little bit more room on the base height and on the top part of the interface. It will also have a pivot point, so it can swivel around it. This allows for obviously to cover a wide range of different tiles and for tile interfaces. All right, this part, the base is 120 up to 170 mil. Other roof solutions. So what do we do when we have concrete roofs? This is a common question, and we come into this question a lot in Clenergy. So we got three different types of solutions, which the first one would be a non-penetrative one, which some systems require us to not penetrate in concrete because it could be, then we could have risks of leaks or anything, or basically when a project is designed for a non-penetrative approach, this is when we have the solar base, which is a ballasted product. Now this product comes with a ballast tray on the front and a ballast bar and a wind deflector. And it is right now up to wind region A and height to 12 meters. So it's ballasted systems are a bit rare in Australia, but we do have them. So in case you have a concrete roof which couldn't be penetrated, we use ballasts. Moving on, the second solution, which would be the most recommended one, would be using Chemset anchor studs. So Chemset is a product by Ramset, basically acts as a chemical concrete, and it seals the membrane. So if you have a concrete roof and it has to be a penetrative approach, the Chemset is very reliable, very recommended, and we only require 80 mil embedment in the concrete. It is up to wind region D and even 100 meters height. So we have installed with concrete penetrative, even I think the highest project was 166 meters in Sydney CBD. So when you require a very reliable product and something of a high capacity anchoring, definitely the Chemset and the solar roof, is up for it. And we can use this on flush or tilt systems and for concrete roofs. Moving on, we've got the third solution, which would be bolted to concrete sleepers. Basically, we can redesign any system to be installed on sleepers, and the sleepers would be placed on the roof, which is also sort of like a ballasted situation there. All right, moving on, if we are unsure and we would like to check how do we design, how do we approach a concrete roof or a system that is installed on concrete, please send us an email at engineering@clenergy.com.au and we'll give you a free preliminary assessment. All right, so moving on, what does the industry want? So we want to save time, we want to be proud of our work, and we want to connect and collaborate with everyone in the industry and help promote the renewables in Australia and worldwide. So with saving time, we have now the Easy Quote tool, which we have updated recently, and we have added new functions. So for those of you who haven't used this is our quoting tool, and it's available on our webpage at www.clenergy.com.au. And in here, you'll be able to access and issue bill of material tools. So as you can see here would be the homepage image of it. And it has roof mount, ground mount, also to quote Easy Shade. Also it's got resources and manual, which offer you all the engineering certificates, installation manual, technical data sheets, brochure, and more. As well as a PV array row spacing calculator, which is very useful when we design roof mounts. This is a little image from the All Energy Australia 2019. We got our technical support team, engineering team, all local in-house departments, and our laboratories are NATA accredited, so all of our gear has been tested accordingly, and it's compliant. So we only provide items of quality and high standards, as we're built to last. Commercial tilt, new defender and rail caps, and the new Hollywood racking gear. This is all coming, and innovations that will make your neighbors jealous of your installation. So moving forwards, we got a little bit of our networking events, Facebook groups, and training workshops as well. We with the Solar Cutters Foundations, and as well as the Clenergy Club. So this is direct feedback when we have all installers and live there, and any feedback from the industry as well as the stakeholder group, which basically are representatives of the industry that give us their feedback and recommendations. So the Clenergy Chronicle also is available for you guys to subscribe on our webpage. At the bottom of the webpage, you can click there and subscribe to get all the latest news, new items, and any updates that we provide. We send them through the Clenergy Chronicle. And there's some links for you to contact us, our webpage, the sales email, and all the links from Facebook, Twitter, LinkedIn, Instagram, Twitter, and our learning group. And to finalize, I will leave this here. This is our CPD training, and please scan this with your phone if you are interested in this CPD training course. I will leave this QR code here for you, those of you who are interested of taking this CPD training. Well, thank you very much for attending today. I will now pass this to Samir.
Cool. Thanks, Andres. That was all very, very informative. And we've already got our first question here. I'm not sure if you can see the Q&A panel on your screen, but if you want, I can read it out. It's from Alan Day. As you will all know, the standard size of panels keep increasing. The panels we now use as standard can't be entered into the design tool, maybe 20 mils too wide. Does Clenergy intend to update the standard certifications to keep pace with this?
Alan, thank you for your question. So in short, yes, we have considered the panels that are new, are coming in increased size and basically the width of the panels. So it's something that we are right now working on it as well, updating our certificates and also the length of the rail that we provide. So it is something that we are considering. That's correct.
Cool. Also, I wanted to mention to everyone listening in today, Andreas did mention various clip lock clamps, and sometimes to ascertain which one you wanted to use, we've created a multi toolkit. So if you go to clenergy.com.au, there we have a online store where you can literally pick up a complete toolkit which has one of every different type of clip lock clamp, and that also comes with the pairing little pairing chart, which lets you know which clamp works with which roof profiles, so that you can basically keep this in your car, and then when you're on site doing the quotation, you can go and check, give them, check with each clamp, and then you'll know exactly which ones you need to order. Cool. So you've got that QR code there for the online test for anyone who needs the CPD points. It's just an online test with 8 questions. Shouldn't take you more than 7 to 8 minutes to fill that in. And once we receive it, we'll get it assessed and then email you your certificate, which you can submit to the CEC and secure your 35 CPD points there. Beautiful. I don't think there's any other questions there on the Q&A channel, but Andreas, recently you did a live event, I believe it was in Townsville. What were some of the common questions you got there?
Yes, correct. So well, typical questions were regarding the rail lengths and how to use it, how to design it. Basically, what do we recommend to use on ground mounts as to the how many rows, how many panels could I fit in rows? So the short answer would be around 30 to 32 panels per row would be recommendable for ground mounts. But look, in Clenergy, we have different types of rails. So we have the standard Eco Rail, then we have the T50, T110, and the T150 range, which is also heavy duty. So we've got different types of rail for which we have calculated the maximum deflection points and the capacity to use these rails. So it can depend on sometimes the rail that you select for some purlins and different scenarios.
Thanks, Andreas. We've got another question come in from the Q&A from Idris Khalifa. His question is, do we need to use catenary wire for earthing?
Catenary wire. I'm really unsure of this question, but Idris, if you want, I can raise this with our tech team just to double check, because normally it's not required any specific type of catenary wire for earthing. It's just with the lugs and the clip, that will do.
Actually, we've got a couple of more questions come in.
So Alan, the Solar Terrace 2A, the frame is a steel frame. So if we secure the panels with the grounding clips on the top, then we will have successfully grounded the whole structure. And the C-post is steel, so it assures continuity to the ground. So it's not needed to have an alternative path to the grounding.
Doesn't look like any more questions there, Andres, for us. Beautiful. Thank you, everyone, for tuning in today. Really appreciate you making the time. From everyone at Clenergy, thank you, and have a good rest of your evening. Bye-bye.
Thank you very much.